Thank you for watching AutoDrill videos. This is a tutorial instructional video for this particular job here. We have actually a 9 drill, technically 10 drills, but it's a spare unit, but 9 drills that will be running simultaneously that will be air driven. Over here you'll see the control for the 9 drills. We're going to just go through step by step. It's a lengthy video, but just want to touch base on some of the critical components of this control operation. Essentially here, this is a standard FRL with a dual manifold for controlling the operation of this drill. Over here you're going to see the input. This should be a 3/4 inch tube or 1 inch tube. For this input is a 3/4 MPT in here that runs into the main FRL. I want to just note here that this label indicates that this FRL, the regulator, cannot be set below 90 psi. It's very critical that this has sufficient airflow. So if your compressor, say, is set at 100 psi, which I would definitely recommend that, or higher, it really gives a little bit of leeway that as the air is being consumed by all the motors and the drills, that hopefully we never drop below 90 psi, ensuring that this entire control operation will flow and continue to operate successfully. It then comes into this this junction here, where we continue to supply the air into this manifold, which this particular line, which is line 5, is controlling all the airflow for these air motors. These will go to the individual air motors, which you'll see here: motor 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's actually being fed on both ends. We wanted to make sure there was sufficient airflow, so it gets fed from this side of the manifold, hard piped right in here, and then this 3/4 inch hose comes around. It jumps over with a 3/8 tube, and it comes right over here to this number 5 port, which you can see over here. 5 is reflecting the air supply for turning on the air motor. 1 is actually an exhaust. You can see that on the other end if you get over there. And then the number 3, if this were a drill valve, it would control the retract. But in this particular case, the only thing that it's going to be getting air on this port is the clamps to open. So I'll come back over here again. So the air feeds over there to that side, then jumps over here with this 3/8 tube, which would then supply air to this 1/4 inch channel over here. First it comes across and it feeds this DP. You'll see over here this regulator cannot be set below 60 psi. This is actually very critical. This is doing a number of different things, as well as controlling the drills from extending and retracting, but it's actually sending a number of different signals to all these valves. If this gets below 60 psi, we actually run the risk of not having sufficient pressure to actuate certain valves. It could cause the entire control to get hung up, and troubleshooting it is very cumbersome. So we don't want that to get below 60 psi. So this is actually really very critical that this does not get below that. But essentially, this will supply air to all these parts of the valves here, which I believe is the number 5 as well. And this is basically controlling the supply air for all the extend. You'll see over here this green tube, which I'll get to later on. This basically is illustrating the extend air pressure. So all these valves here go to all the drills, and that'll do the extend air pressure. There's a jumper that you see over here. This little 1/4 inch tube jumps over to the number 3 side of this manifold, and it's actually sending the air signal for all the retract. To make sure that there was sufficient air, because this is only a 1/4 inch line, we actually had a secondary jumper come over here that was supplied from down here, and it comes to the other side. So there's actually 2 1/4 inch tube lines feeding this entire manifold on both sides. So it's getting sufficient air for the retract. We actually did multiple tests here, and they extended and retracted pretty easily. So we're actually happy with that. It also is supplying air. If you see this tube down here, it's coming down, and it's supplying air to this tiny little manifold. You'll see this label says supply air to all the limit switches. Every drill has its own independent limit switch. Actually, I'll show you a quick illustration over here. This limit switch, which is on every single drill, is needed for the controls to know when the drills have reached their end of stroke. Essentially, once this drill extends, this little fastener right here will engage this plunger. When it pushes this plunger, the supply air that is coming in here, you see through this arrow, which is critical, make sure the air comes in, follows the arrow, will then go out, and as you can see, this little blue tube indicates where it's coming back to on the drills, the drill valves. All these represent the return air coming back from those limit switches. You can see these valves are all independently labeled, drills 1 through 9. And so that basically would send the signal to these valves, actuating the valve over and then sending the drills to the retract position. Now, aside from that, there's a couple other key components a part of this process. First, I want to start with the actuating buttons, and then we'll work ourselves through the process to show exactly how it works. The little button over here, which has a red indicator on the front here, essentially you'll see a warning. Do not push if the drills are not retracted. Essentially what happens is this is opening up the clamps. The supply air is coming right over here. This tube happens to be labeled number 19. We'll see that over there where that's getting its air from. But essentially the supply air comes in here, jumps over, and it's going to hit this clamp valve. When the air supplies is over here and shuttles this over, this little tube, this quarter-inch tube, comes down here. This opens all three clamps, clamps 1, 2, and 3. So once the clamps are open, that allows the operator to load the part or parts and then begin the process. Once the clamps are in the open position, the operator will hit these two buttons simultaneously. Essentially, these buttons need to be removed from this manifold, or from this mounting table, and probably moved to a more strategic location. Also, I would definitely recommend that this tube be lengthened so that the buttons are farther apart, so that the operator could not simply use one hand to hit both buttons at the same time. But when he does hit these two, hopefully separately but simultaneously, that would then actuate the clamps to close. It would send an air signal to this two-hand anti-tie down, which then will shuttle out and send a signal right over here, number 23. And you can see it would basically close the clamps. Once the clamps are closed, this little tube here, number 21, will supply air to these buttons. This is the buttons that will be used to start the drills. If the clamps are not closed, these two buttons will not work. The supply air will not feed these two buttons if those clamps are not closed. So that's kind of a safety mechanism we put in to ensure that the clamps are actually in the closed position and that it's safe now for the operator to start the operation. So once he hits the start button, number 22, you'll see this little tube here is actually all the way up here. It goes to the first, I'm going to move this real quick so you can see in there. It goes to this first valve, which we call the control valve. Once that's shuttled over, it's going to do a number of different things. This quarter-inch supply air is actually going to feed into this splitter. First and foremost, it's going to send an air signal to this manifold way up here, which is supplying air to all these 9 drills. Over here, you'll see these independent shut-off valves that will allow the operator to choose which drill he wishes for it to be off and which drills he wishes for it to be on. So by turning the valve in the off position, the supply air will not get to this drill. The drill would not extend. It will stay in the retract in the home position. If he has them all open, essentially the supply air will go to all of them and all the drills will extend. Once the drills get the signal to extend, and they are extending, there are splitters here. All these signal tubes, which you'll see labeled 1 through 9, is going to send a pulse air signal through this line to over here. These are the number 12s. Both sides of these both manifolds, the number 12 represents the start signal. Once the supply air goes to all these number 12 ports, it will then actuate these drill motors to turn on. So again, if that shutoff valve is off on one of those drills, that particular motor will not turn on. It's critical that these numbers match up with the same valve on the adjacent manifold. So essentially, if motor 7, which has a number 16 tube here, it's getting supply air from drill 7, and you'll see that it has a number 16 tube. So it's imperative that those two processes work that way, so that everything is working properly. Once the drills extend, they will turn on these motors. They'll hit the limit switch. They'll get a signal here to retract. Once they shuttle over and is now retracting, which will come out of these ports, you'll see the air signal come around and actually turn off all the motors. The air will then come out of here, which these ports are all plugged. This particular tube, which is the clamp valve, will come down here and actuate the clamps to open. That's only when this button is pushed. So this always has a constant source of air. Actually, that's not true. It's not a constant source of air. This will be enabled momentarily after the drills are actuated. Actually, when the drills are started, and we'll come back over here again, when the air comes over to the number 22, which is this 12 port, it actually sends the air to here, to this splitter, to the manifold we discussed before, but it also goes to this timer. This timer is set for approximately 3 seconds. After about 3 seconds, which gives the drills more than enough time to start the extending process, it will actually shuttle over a pulse air, turning this control out valve off, shuttling it back over here. This tube, which is slightly hidden behind this muffler, which is labeled number 20, does supply the air to this control. So I apologize, actually that's not true. When the drill's in the retract position, it's supplied air from this splitter. That's actually something I did want to mention on this video. The number 19 point part here represents the supply air to this valve, to this button to open the clamps. There is a slight problem with this in the sense that if you were to turn off the first drill, the number 1 drill, and left it on the off position, you started all the drills, because that one stayed in the retract home position, you could theoretically open the clamps at any time. Obviously, that's a little bit of a danger, that if the drills were in the part and the operator was to hit the clamps to be opened, that could be a very dangerous situation. Aside from that particular drill being turned off and staying in the home position, once the drill is in an extend position, this can never be opened because there will be no supply air coming to it. It's only if the drill number 1 is turned off. So I don't know if there's a particular drill that will never be turned off, but if that is the case, let us know and we will walk you through to changing this to a different port so that we can ensure that this danger is removed. But that's essentially it. That's the entire process. Those are the key components. You will see when you get the controls in your hand, on each of these tubes, there will be a number. The red will have a number for the retract, the green will have a number for the extend, and the air tube will have this, the motor valves will have this white tube, and it will have a number, and they will actually be on the drill. It's imperative that they match up appropriately. So you will need to make sure that the numbers match up when you connect them together on site. And the white one, of course, will be over here coming out of the air motor. So that's pretty much it. If you have any questions, feel free to give us a call. You can reach us at 800-571-5022 or visit us on the web at AutoDrill.com. And thank you for checking out our videos.